equations. You're going to solve trig equations using identities and algebra. Helpful hints, these are not steps, they're just helpful hints. Decide whether the equation is linear or quadratic in form so you can determine the solution method. If only one trig function is present, solve the equation for that function. If more than one trig function is present, rearrange the equation so that one side equals 0. Then try to factor and set each factor equal to 0 to solve. If the equation is quadratic in form but not factorable, use the quadratic formula. Check the solutions that are in a desired interval. Remember, look for your domain and range. Try using identities to change the form of the equation. It may be helpful to square both sides of the equation first. If this is done, check for extraneous solutions. Anyway, solutions that you get but won't work. Okay, so the first one here. Solve each equation for exact solutions over the interval of 0 to 2 pi. No squared, only one trig function, so we're just going to solve for sine of x. Okay, so we subtract 2. Okay, let's try this again. Subtract 2 from both sides. You get sine of x equals 1. Then you do the arc sine on both sides. So arc sine of x, arc sine of sine of x equals the arc sine of 1. These will cancel out. So you're left with x equals the arc sine of 1. Now in 6.1, they use that table. Hopefully you made a copy of it. You still have it in your notes. That tells you that sine is going to be quadrants 1 to 4. Actually, they're telling you 0 to 2 pi, so we're just looking at all of them. Never mind that. So we're looking for the angle with a sine value of 1 in this interval. And that would be x equals pi over 2. Because the sine of pi over 2 is 1. And that's all we have to do. Okay, number 14. We have secant on both sides. So we move this secant to this side and this 1 to this side. So subtract secant of x, subtract secant of x, and 2 minus 1 is going to just give me 1 secant of x, plus 1 equals 3. These will cancel out. Subtract 1, subtract 1. So secant of x equals 2. So you do the arc secant on both sides. It's kind of like having something squared and doing the square root on both sides. Equals the arc secant of 2. Again, these guys cancel out. So we have the arc secant of 2. Now, unit circle, again, this is where those unit circles are going to come really, really handy. But unit circle doesn't have secant. But you guys know your reciprocals now. And so 1 over secant equals cosine. So I can rewrite this as arc cosine of 1/2. Notice I took the reciprocal of both. Reciprocal of secant is cosine, reciprocal of 2 is 1/2. Now look at your unit circle and find where cosine equals 1/2. And this is where all students take calculus comes in handy, because cosine is positive here and positive here. So this is going to be pi over 3, and in this quadrant it will be 5 pi over 3. So there are your 2 answers. Unless it's a quadrantal angle, you should get 2 answers every time. Quadrantal angles, only if it's 0 where you get 2 answers. Okay, this is going to come in handy if you have this table or if you're using the unit circle. So we'll go ahead and fill this one out. That way you can refer back to it if you need to. So sine at 0 is 0. 1/2 radical 2 over 2, radical 3 over 2, 1, negative 1. I lied. This is negative 1. This one is 0. And on just these ones here, we can go backwards on these. Cosine here is 0, 1/2, radical 2 over 2, radical 3 over 2, and 1. And pi is negative 1. Yes, these are going to flip-flop also. Tangent is just sine over cosine, so 0, radical 3 over 3, 1, radical 3, undefined, 0, undefined. And then cosecant is just a reciprocal of sine, so 0, 2, radical 2, 2, radical 3 over 3, reciprocal of 1 is still 1, undefined, reciprocal of negative 1 is still negative 1. Secant is reciprocal of cosine, so 1, 2, radical 3 over 3, radical 2, 2, 0, undefined, negative 1, undefined. And then cotangent is reciprocal of tangent, undefined, radical 3, 1, radical 3 over 3, undefined will go to 0, undefined, and 0. Now, I don't care if this is only giving you reference angles. So if you're using this, you'll have to remember how to get to those reference angles. So I'll use reference angles from this point on, quadrant 1 in the unit circle, and then reference angles. This is quadrant 1. Okay, so this one here, we have a nice little square, we have a radical, a lot going on in this one, but I don't have a constant, which is kind of nice. So this is the one where they're telling you, try to factor out things. Now, if it's difficult for you to do the algebra with trig in there, take the trig out. I'm going to let x equal cosine of x. Okay, anyways, let x equals cosine of x. So now this is 2x squared minus radical 3x equals 0. There's a common factor of x in both of these. So I'm going to factor out an x. So I'm going to put x times 2x minus radical 3 equals 0. So either x equals 0 or 2x minus radical 3 equals 0. This one's done. X equals 0. Solve this one. So I will add radical 3 to both sides. So we have 2x equals radical 3, x equals radical 3 over 2. But please don't forget to go back and, oh yeah, I'm playing with cosine. So this is cosine of x equals 0, and this is cosine of x equals radical 3 over 2. Cosine of x equals 0, we can go back to this page. This is the only time I'm going to do this. We go, oh, cosine at 0 happens at pi over 2 and 3 pi over 2. So here we get pi over 2, 3 pi over 2. And on this one, again, that all students take calculus. So quadrant 1, we're going to get, and we come back over here, cosine, radical 3 over 2, go, oh, that's pi over 6. So in quadrant 1, pi over 6. And in quadrant 4, it's going to be 2 pi, or 360, minus pi over 6, which gives us in quadrant 4, 11 pi over 6. This is one of those, for those of you who really like the algebra, you're going to enjoy these because it's nothing but algebra. And in the end, you have a trig step. Okay, let's look at the next one. Okay, a little bit more involved on this one. 2 cosine squared of x minus cosine of x. So I'm going to do the same thing. Let x equal cosine of x. So I have 2x squared minus x equals 1. You have to set this equal to 0. You cannot solve this one with the 1 over here. So subtract 1, subtract 1. So I have 2x squared minus x minus 1 equals 0. And yes, you have to do the little factoring here. Most of you guys know this is the wagon wheel. I'm going to introduce you guys to Vincent's rule. Okay, 2 times -1, -2. This term in the middle goes here. I need factors of -2 that add up to -1. This guy is odd, so one's going to be positive, one's going to be negative. So since this is negative, it's going to get the larger value, -2 and 1. -2 times 1 gives me -2. -2 plus 1 gives me -1. Vincent's rule tells you to take the negative version of this guy. So -2, -2. And you're going to get your answer of x equals -2 over -2 is 1. Or x equals -1/2. You do not have to factor this thing down. I don't care that you can factor it. Can you get to the answer? That's the question. Don't forget, x is really cosine. So I have cosine of x equals 1. And that's going to happen at 0. We can go back to this again. Cosine of x equals 1 at 0. Now, for those of you guys going, why aren't you using 2 pi? Because the parentheses indicates 2 pi is not included in our interval. There you go. I went too far. Went the wrong way. Okay, back to this one. So only half the time it happens is 0. The other one is cosine of x equals -1/2. This happens if we do the all students see calculus. This happens in quadrants 2 and quadrant 3. Now if you come back to here, cosine 1/2 is pi over 6. I'm sorry, pi over 3. But we don't want pi over 3. We want the angle here. So pi over 3 is a 60-degree angle. Subtracting from 180, you get 120 degrees. But I don't want degrees, I want radians. So you got to convert this back to 2 pi over 3. And then this one is going to be the 180 plus 60, or 240 degrees, which is going to be 4 pi over 3. I think you may find it a little bit simpler to use your unit circle than to use that, to use the table. But then again, the table may help you get to the values on the circle faster. Okay, let's try another one here, get you a little bit different problem on you. So cosine squared, this one they are asking you for the answer in degrees, so it might be a little bit easier for you. But notice I have cosine squared and sine squared, so you're going to want to change one of the two. It doesn't matter which direction you go. You want to change one of the two to either cosine to sine or sine to cosine. I'm going to change the cosine to sine using my Pythagorean identity. And no, you could not just square root both sides. The identity doesn't work then. So this is going to give me 1 minus sine squared equals sine squared plus 1. Since I only have the one value here, which is sine, I'm going to move this sign over because I don't like the negative. So plus sine squared gives me 1 equals 2 sine squared plus 1. Subtract 1, and I get 0 equals 2 sine squared of theta. Okay, equals 0. Divide by 2, I still have sine squared of theta equals 0. And this occurs at 0 and pi, but we want it in degrees. So 0 degrees and 180 degrees is when this occurs. Okay, these are more along the basic, more simple problems. I hope that you guys would agree as we move on. The next video will show the ones that are not so easy. So I have already adjusted the homework, so we're going to kind of fast forward to the homework page. And on the homework page, we're going to cross these out. And it's, I believe it's 11 through 33, every other odd. It's going to give you 6 problems. And that's it. I was looking at that last night. So good luck. Go ahead and get started on this homework.